In the final stage of a cashew nuts production line, human laborers are required to perform a final manual quality check to eliminate faulted cashew nuts before packaging and distributing. However, the task is repetitive and also requires high concentration, which may not be always satisfied by humans when working intensively in long shift. As a result, we have designed an automated sorting machine to reduce labor resources and cost, which can significantly contribute to companies' productivity. The system proceeds as follows. Firstly, the cashew nuts are fed through a computer vision system, which will perform detection and classification between standard and faulted cashew nuts. Then, as the conveyor belt transports the products, the Delta X robot will pick and place the detected targets outside of the production line, while the qualified products go to the next stage. For the machine vision system, Basler A's industrial camera was implemented for both collecting the dataset to train the model and performing real-time object detection of the samples. The camera is equipped with a global shutter and CMOS sensor, be able to deliver up to 25 frames per second at 4 megapixels resolution. It also prevents image distortion and light reflection from the conveyor belt. To train for an object detection model, we apply YOLO V4 Tiny, an algorithm proved to deliver a model that has high accuracy and fast inference speed. The model is trained with a dataset of 1500 samples, including both standard and faulted cashew nuts. As a detected target moves through the activation line, its coordinate will be sent to the Delta X robot for the pick and place operation. Without the need of a graphics processing unit, YOLO V4 Tiny object detection model can deliver up to 8 frames per second with the average accuracy of 90%. For the pick and place operation, we use a combination of robotics arm and pneumatic system. As for the pneumatic system, the air compressor supplies air to the system with a pressure of 6 bar and 200 liter per minute of airflow. The compressed air travels through the tube to the next component called air preparation unit. The next step is to direct it through a directional valve control, which is operated by a digital signal. The next component is an ejector to create vacuum feature. The last component approaching the picked objects is 2.5 bellows suction cup. The holding force of the system is 1.5 Newton. The Delta X robot has 4 axes, a working diameter of 600 mm, with accuracy up to 1 mm and repetition of plus minus 0.1 mm. It can reach a maximum speed of 3 meters per second and a maximum acceleration of 50 meters per second square. The conveyor belt is run at 45 mm per second, and the system has an encoder to keep track of its constant speed. After receiving the initial coordinate of faulted nuts from the camera, the robot system keeps updating the position of the nut every 0.1 seconds until it moves into the picking circle. Then, the vacuum is triggered to turn on, and the end effector starts to move from the drop-off area to the moving targeted nuts. The accuracy of the position prediction algorithm is plus minus 2 mm in y-axis and lower than plus minus 1 mm in x-axis. Finally, it places the faulted nuts at the drop-off area. Together with the fourth industrial revolution, the project is expected to introduce a solution that emphasizes the advantage of automatic technology to local Vietnamese factories and maximize their profits from the era of automation.